He was basically working on creating a formula to have ultra-clean diesel for a project that the government and Pemex, they wanted to, I guess, raise the standards of cleanliness, lower the standard of emissions, I guess would be the way of looking at it. Because Mexico's standards were kind of not that tight, and they're aiming at making that a lot tougher and a lot stricter. So George was working on that project with Dr. Juan Navarrete from the Mexican Petroleum Institute, and a few other things. So I'll let George tell you about his story. Thank you.
Thank you very much, Nicolas, for that introduction. And well, good night, ladies and gentlemen. And well, my name is George Wang. I'm currently a junior at ASF. And first of all, I would like to give thanks to everyone for this honorable opportunity for me to be on stage tonight at ASF Talks. So I'm going to be presenting a project that I worked on last year at the Mexican Petroleum Institute. So it's the investigation of a new technique for basically removing the sulfur for cleaner diesel production. So last November, I presented this project at the 4th Junior Science Cup, and fortunately enough, I got 2nd place. And thank you. And I was also selected to be part of the Mexican delegation team to represent Mexico at the Genius Olympics and this June in New York. Thank you. But before we start, let me tell you where my journey begins. And my journey begins freshman year. That's 2 years ago. And during 2nd semester, the school organized a trip to the Nevado de Toluca. And honestly, the hiking passed quickly. It was the 4th day, and I was named the captain of my team to encourage others to not give up and to finish this trip successfully. And when my peers and I reached the top, I saw the unexpected. It was a beautiful view towards Mexico City, Puebla, and Toluca, but also a beautiful view towards a thick, gray, and dark cape over these beautiful cities, which was basically pollution. It was truly an eye-opening moment for me, and I realized that if I could do something to change this, I would. So I started to investigate. During my investigation, I found out that automobile emissions were responsible for more or less 70% of the air contamination in cities. As we all know, vehicles in the cities, they mostly use diesel and gasoline as their main source of energy. And well, when they're burned, they're released into the environment as COX, SOx, NOx, and some other small particles. And they basically contribute to pollution, acid rain, and acid snow. As a result, 30 years ago, a three-way catalytic converter, which was installed into cars, and this catalytic converter basically transforms CO into CO2, NO into nitrogen, and hydrocarbon into CO2 and water, which basically makes the COX and the NOx a more reliable gas for in order to pollute less. And so, but however, what about the sulfur? The sulfur basically poisons. If it goes through the catalytic converter, it basically poisons it. Contributes to health problems and pollution. So the sulfur has to be removed before the combustion happens in order for the catalytic converter to work. So in this image, it shows the sulfur emissions around the world. So we're able to see here in like North America and many countries in Europe, they have a low concentration of sulfur, which is below 15 parts per million. And in Mexico, here, they're between 50 to 500 parts per million. And well, 11 years ago, la Asociación Mexicana de la Industria Automotriz, they made a regulation for the diesel concentration to be lower than 15 parts per million. However, Pemex didn't have enough resources to upgrade their refinery, which made this regulation impossible to be followed. So last year, in 2016, a new regulation was made that in 2026, they guaranteed that in 2026, the sulfur concentration would be lower than 15 parts per million. So the general objective of my project is to develop a new method to remove the sulfur from the diesel in order to meet the standards of these increasingly strict regulations. So I designed a reaction system which consists of 5 components. The first component is a catalyst, which is a tungsten oxide. And what it basically does is it speeds up the process of the reaction process. An oxidant, which is hydrogen peroxide, it brings up the pH level so that the reaction system can occur properly. And the promoter, which is an acetic acid, a solvent, which is acetonitril, and the diesel, which is a model diesel called hexadecane. And so this is the experimental methodology. The temperatures of the experiment were kept around 50 to 70 degrees Celsius, and the reaction times were kept under 1 to 2 hours. These photos were taken with a transmission electronic microscopy, which was part of in Mexico, the Mexican industry of petroleum. They provided me with these images. And in image A, we're able to see parallel channels, which these are all from the catalyst. In image B, we're able to see ordered pores that are very similar to those of a beehive, which is here. And in image C and D, they're nanoparticles that are filled up with a tungsten oxide on the surface of another catalyst. And this tells us that the catalyst is working properly. So I know this is very technical, so just bear with me. So these are all the results from my project. And so point 1, keeping the same catalyst and increasing the temperatures, we were able to see that the DBT conversion, which is extraction of sulfur, would also increase, and also increasing the amount of catalyst will also increase the DBT conversion, and adding a promoter. And basically, we can see that at 15, we're at 60% of the temperature, we were able to remove 99% of the sulfur from the diesel. So these images also explain the process. So in the first one, the sulfur is absorbed into the catalyst, and through a process of oxidation, it becomes a dibenzothiosulfone. The second picture, this one, it shows the acetonitril, which is the solvent, and we added the diesel, and inside the diesel we were able to see the particles of the sulfur, and to this mixture we added the solvent, the tungsten oxide, the hydrogen peroxide. We mixed all that up, and we were able to see that the solvent was transformed into a polar phase, which basically removed the sulfur from the non-polar diesel. And so the conclusion is that it is possible to perform both the DBT oxidation and the sulfone extraction from one reaction system, and that oxidative desulfurization, which is the technique that I used, is a promising alternative for the production of ultra-low sulfur fuel. And well, I wanted to thank Dr. Juan Navarrete for his guidance, and also everyone, the ASF alumni, Ms. Paloma Fuentes, for giving me this opportunity to be on stage. And well, Thank you very much.